Welcome to VGuide TV channel. In this video, I am going to discuss the few cases of prism. Already in one previous video, I discussed about refraction through a prism derivation. Here I am telling only the equation. This is a prism. In this prism, this is the first refracting surface. AB is your first refracting surface. BC is your second refracting surface. The light ray is incidentally on this surface, getting refracted and gets emerged like this. This, if you draw a normal, this is the angle of incidence, angle of refraction. The light ray is emerged like this. Here also you draw a normal. This is your I2, this is your R2. If you extend the incident ray backward as well as refracted ray backwards, the angle formed is called deviation. Okay. So, I can write the deviation is nothing but I1 plus, it is, you can just write it, this is an exterior angle, it is the sum of interior angle. So, these two are the interior angles. So, this angle I can write I2 minus R2, this angle I can write I1 minus R1. So, delta I can write I1 minus R1 plus I2 minus R2. That is I1 plus I2 minus R1 plus R2. That is delta I can write I1 plus I2 minus A is the equation for delta deviation. Angle of the prism I can write as, we are using the quadrilateral formula and we know that we can find out what will be this angle. This angle I can write R1 plus R2 derivation, we did it before. Then in this situation I can tell if I1 equal to 90 degree, your deviation will be maximum and that is called delta max, that is 90 plus I2 minus A. If you want minimum, it is 2I minus A because we take the condition I1 equal to I2, R1 equal to R2, refracted ray is parallel to the base. Refracted ray is parallel to the base. This condition is called minimum deviation and this is the graph. Okay, this is the graph for that. Delta and I. As I increases, delta get decreases and then again it get increased. Now look at the first case. In the first case, it is the normal incidence case. Normal incidence here means your light ray is incidenting normally to this face, normal. So if you draw a normal here, this normal and incident ray, they both are parallel. Right. So first case, the light ray is incidenting normally to the first face. If the incident ray is normal, refracted ray also should be normal. So I can write two situations, I1 equals R1 equals 0 because it lie along the normal. Then what happens to your A? R1 plus R2, this is 0. So we can write A equals R2. What is called delta? I1 plus I2 minus A. So here I can write I2, I1 is 0. So we can write I2 minus A. A we can write as R2. So I2 minus R2. This is the case for normal incidence. If you want normal emergence, that means the light ray emerging normal. The light ray, the emergent light ray is coming like a normal. So if light ray is emerging normal, we can write I2 as 0 because if you draw a normal here, these lie along the refracted ray only or emergent ray only. So I can write I2 and R2 are 0. If I2 and R2 are 0, what happened to your A? A equal only R1. What happened to your delta? I1 minus R1. Okay. Third case. It is called grazing incidence. It means light ray is grazing along the surface. If you draw a normal here, angle of incidence. Angle of incidence is 90 degree. If angle of incidence is 90, here what we are doing is, you see, angle of incidence is 90, angle of refraction should be critical angle. It's a very important condition. Okay. So we know that if I1 equal to 90 degree, R1 should be equal to C, critical angle. If R1 equal to C, what happened to your A? A will come as R2 plus C. Therefore, the deviation I can write it as, what is the deviation? Deviation I can write it as 90 plus I2 minus A. We already discussed, that is called the maximum deviation. That is called by the name maximum deviation. Okay, grazing incidence. Fourth case is grazing emergence. Grazing emergence means the emergent ray grazes along the surface. So I2 is 90, R2 will come as C. Okay, what happened? I2 is 90, R2 will be C. Then what should be your A? A we can write it as R1 plus C. So what happened for the deviation? I1 plus I2 is 90 minus A. This is the deviation. These four cases are very important. Okay, in the question they will give like a grazing incidence, grazing emergence, or normal incidence, normal emergence. What should be the deviation? So in this way you can calculate. Now, next case you see, if a light ray is incidenting normally on one face of the prism, an emergent ray just grazes from the second surface. So they are given two situations. Light ray incidenting normally. So we know I1 and R1 should be 0 because normal means it is lying along the normal. Incident ray and the normal along the same line. So I1 equal R1 equal to 0. If I1 equal to, then next they are telling emergent ray grazes. It means that I2 will be 90. If I2 is 90, what should be R2? R2 should be C. Therefore, we can write A equals R1 plus R2. A equal to R1 plus R2. R1 is 0. So, we can write A equal to C. Very important situation. So, I can write what is the equation for N refractive index 1 by sin C. 1 by sin C we can write it as 1 by sin A. So remember they may ask like this, at what situation 1 by sin C should be equal to A? 1 by sin C should be equal to 1 by sin C is equal to 1 by sin A. So N equal 1 by sin C is equal to 1 by sin A. Next, what happened for the deviation in that situation? I1 plus I2 minus A. I1 is 0. I2 is 90. So 90 minus A or 90 minus C. I can write if a light ray grazing the first phase and emerges out normally from the second phase. What is happening? Light ray grazing at the first phase and emerges normally from the second phase. Then just reverse condition. I2 equal R2 equals 0. R1 should be equal to C. I1 should be equal to 90 degree. So these situations you have to remember. Okay, I hope you understood what I told. You have to take the situation of, here the first case is incident ray is normal and emergent ray grazes. Second case they are telling incident ray, light ray is grazing through the first surface and emerges out normally. Next. This is a very important question they ask for JE and all. That is the limiting angle of incidence they'll ask. Limiting, what should be the angle of incidence limiting value? So for that what I'm doing is the light ray, for light ray to emerge grazing from the second surface, we are taking the condition that emergent ray is grazing. That is called a limiting angle. Means here the light ray is going from denser medium to which medium only? Rarer medium. So critical angle situation is the limiting condition. Critical angle condition means what will happen if this is grazing through the surface means this should come as 90. Your I2 should come as 90. If I2 should come as 90 means what should be R2? R2 should be equal to C. So I2 in this case I2 is coming as emergent grazing along the second surface means I can take I2 is 90. R2 should be C. So what should be R1? A minus C. Then I am applying your Snell's law. Snell's law says sin I1 by sin R1 equals N. What is sin I1? That is N sin R1. That is N sin, what is R1? R1 is A minus C. That is equal to N. Here I am applying the trigonometric relation sin A minus B. Sin A cos B minus cos A sin B. So it is sin A cos C minus cos A sin C. That is sin A into, what is cos C? Cos C, I can write it as n equal 1 by sin C. Sin C is 1 by n. So what is cos C? Root over 1 minus sin square C. That is root over 1 minus 1 by n square. Taking the LCM, n square minus 1, root over n square in denominator, it be 1. So remember, cos C I can write as root over n square minus 1 by n. So I am writing here for cos C as root over n square minus 1 by n. Cos A into sin C is 1 by n. This n cancel with this n. Okay, so both the denominator n get cancelled. So I can write sin A root over n square minus 1 minus cos A. Or limiting angle of incidence I1 equals sin inverse of sin A root over n square minus 1 minus cos A. So I need to tell one thing, what is called limiting angle of incidence. So it means I need to find this angle of incidence. At that condition, your angle of emergence should be equal to 90 degree. If angle of emergence is 90, I know that angle of incidence on that face should be equal to critical angle. So I found what is R1. I applied Snell's law for the first surface. After that, the value of n we are writing in terms of critical angle. So n equal 1 by sin C equal to 1 by n. This is the main equation for critical angle. And we are writing cos A in that term. So I get I1 equals sin inverse sin A root over n square minus 1 minus cos A. This question in many exams they asked. Okay, limiting angle. Same way you can find limiting angle of a prism. It means A value limiting angle they can ask. So see A value, this is your A, right? So for that, what should be the condition? It is the angle of prism for which a ray grazing on one of the face of the prism and after refraction it grazes out from the second surface. So it means that here also it should graze and while emerging out also it should be graze. Understood? Limiting angle of a prism means angle of incidence is like incident ray grazes through the surface, emergent ray also grazes through the surface. So it means that I1 and I2 both are 90. If I1 and I2 both are 90, what should be R1 and R2? They both should be equal to C. So what should be A? A should be R1 plus R2. That should be A equal to C. Okay. So this is the condition. Now I am taking 3 cases. In the first case, if your A is lesser than 2C, the refraction takes place at both the sides. If A is equal to 2C, the light ray grazes. If your angle of incidence, if your A angle of prism is greater than, if it is greater than 2C, total internal reflection takes place, that is no emergent ray. So I can take this condition as A by 2 greater than C. So it means that sin A by 2 greater than sin C. That is sin A by 2 greater than sin C, I can write 1 by n. That is, if you take this one, n equals 1 by sin A by 2. That is nothing but cosec A by 2. So n should be greater than cosec A by 2. Very important condition. This also they ask for exam. N greater than cosec A by 2. I can take this in another form. Same thing. N equal 1 by sin C. We can write it as 1 by sin A by 2. We can write it as cosec A by 2. We can write that also equal to root over 1 plus cot square A by 2. Cosec theta we can write in this form. Root over 1 plus cot square A by 2. So any form, I have seen the questions like this. I already did this type of many questions. Root over 1 plus cot square A by 2. So these conditions they will ask. If A is lesser than 2C, refraction take place. It means that it won't grazes. If A equal to C, it will graze. But if it's greater than C, there will not be any emergent ray. It will be total internal reflection. Then I can find the angle of deviation in this case. What should be the angle of deviation in this case? D equals I1 plus I2 minus A. What are I1 and I2? Both are 90. 90 plus 90, that is 180. 180 minus A, that is 180 minus 2C is the equation for deviation. So what I did here is limiting angle of a prism. What should be the limiting angle? It means that A should be equal to 2C. A should be equal to 2C. Why A should be? At limiting angle, what should be deviation? 180 minus 2C. This question only I have seen. A limiting angle means A should be equal to 2C. And what should be the deviation in this case? 180 minus 2C. And I gave you limiting angle of incidence. What is equation? I1 equal to sine inverse of sine A root over n square minus 1 minus cos A. This no any form they can give. Sometimes they'll give it in this form. Sometimes they'll keep it in this form. So any form they can give. And see, I gave the condition of what is called grazing incidence, what is called grazing emergence, what is called normal incidence. So remember, normal incidence means normal refraction. That is a very important concept you should have. If I1 equal to 0, R1 should be equal to 0. If I2 equal to 0, R2 also should be 0. Another condition you should remember is if I1 equal to 90, R1 should be C. Just reverse also. So this type of hints you have to remember for solving this question of refraction of a prism. Okay, so these type of questions they can ask for JEE and for other competitive exams. Thank you. Subscribe for more videos, Big Eye TV channel. Thank you.